Do it. 4.1a midsegments of triangles. In Unit 4, instead of proving triangles congruent, now what we're going to do is we're going to do some properties and theorems about triangles. Everything you learn in Unit 4 will have something to do with a triangle. There's going to be some pretty cool stuff like, well, I think it's pretty cool, but I'm a math nerd, so that's just goes with without saying. Anyhow, I'm going to hopefully show you some different properties about triangles, things that you probably have never thought of or done before. First things that we're going to need to do for this worksheet, the midpoint formula. You're going to have to find the midpoint between 2 points. And so if you have a triangle and you need to find a midpoint, it has something to do with this x and this y and this x and this y. If you want to find the midpoint between any 2 points, you add up the x's, divide it by 2. You add up your y's, you divide it by 2. And the average of your x is your average midpoint, and your average of your y's is where your y's midpoint would be. Second thing we need to know, in order to prove something is parallel, they have to have the same slope. So if I want to know if something is parallel or not, I have to be able to figure out what the slope is between 2 points. There are 2 ways to do it. You can use the rise over the run, or you can use this formula, which is y2 minus y1 over x2 minus x1. You are expected to know these formulas. They will ask you on the worksheets what they are. They give it to you on the first one, but they don't give it to you on the second one or the third one, and they will start asking you those questions. Lastly, the other thing that you might need to know is the distance formula. The distance formula is the difference of your x's squared plus the difference of your y's squared, and you take the square root of that. This is the exact same thing as something called the Pythagorean Theorem. I will show you what it looks like when we come to the picture. So, what I did next after those notes that you wrote down is I literally copied the same thing that you have on your worksheet 4.1a. You have this picture. You have question 1, and it has part A, part B, part C, part D, part E. What I figured we're going to do for this is we're going to do number 1 together, and then we're going to start number 3, but I will not do number 3 because really, there's only 3 questions on this worksheet. But I think the hardest part is the first problem. So let's do the first problem together. Part A says, find the coordinate of the midpoint JL, label it point M. And then they give you the formula in case you don't know what it is, but we wrote it down. So I need to find the midpoint between J and L. I need to know where the middle is. Here's how we're going to do. We're going to do it mathematically. We're going to take this x and this y and then this x and this y. Remember, they're in alphabetical order. X then y, x then y. And we're going to call this our first x and our first y, and this will be our second x and our second y. It doesn't matter which one is which. Your answer will be the same if you put the 2 down here or in the 2 there and the 1 there and the 1 there. The little sub 2 and the sub 1 just means it's a different one. It's the second x or your first x. All we have to do is add up our x's, 2 plus 0, and divide it by 2. That's our average for our x's. We're going to do the same thing for our y's. We go to our 2 y's, the 0 and the 6. We add them up and divide it by 2, and then we're going to simplify that. Most of you can do this in your head, but if not, use a calculator. 2 plus 0 is 2, divided by 2 means our average is 1. 6 plus 0 is 6, divided by 2 is 3. Most of you can do that in our head, and this is going to be labeled point M. M is the midpoint. It's at 1, 3. Over 1, up 3 is right here in my picture, labeling it point M. Pretty simple. The hard part is you will be expected to do this on your test without the formula given to you. You should be able to figure out what the average of 2 points are. And here's the thing. Look at your J and look at your L. Well, if the J's at 0 and the L's at 2, then your average of your X should be at like 1, 3. Like the average of your X's is 1. It's in the middle between 0 and 2. What's the middle between 0 and 6? 3. It should make sense to you. Let's do part B. Find the coordinate of the midpoint of JK. Label it point N. So JK is now a different side. We're talking about this side. We already have x1 and y1. I'm going to label this as x3, y3 because it's my third x and my third y. And guess what? The formula still works for it. Don't be confused by this x2, y2. It just means your separate x and your separate y. I can do my average of my x's and the average of the y's. Same exact thing. I'm going to take this x and this y because I'm finding the midpoint of JK. 0 plus 4 for the x's. And how about 0 plus 2 for the y's? Most of you will be able to do that in your head. 4 divided by 2 is 2. 2 divided by 2 is 1. This is the midpoint, and I usually put the letter next to the midpoint so that I can go over to 2, up 1, and label this midpoint N, and I usually will put 2, 1 in the picture so I know where it's at. The next thing it asks us to find the slope of MN and LK using the slope formula. Justify mathematically why they are parallel. Well, we got to find the slope of MN. I'm going to draw MN. If you didn't know what MN looked like, here is the line. I'm going to draw a nice straight line with this computer. Sweet. There's MN. Find the slope. How do I find the slope? Here are my coordinates. I just do y2 minus y1 over x2 minus x1. I'm going to take the y, or the x's, the y's. 3 minus 1. 3, take away 1. If I do the top one minus the bottom one, on the bottom I have to do the same order. 1 subtracted by 2. Do not switch direction. Always go the same direction, meaning if I did 3 take away 1, then I have to do 1 subtracted by 2. If I go this way, then I have to go that way for the bottom one. And this is the slope of MN. MN, and I'm going to put the slope. MN with a little sub M with it. Why did I do that? So I know that I'm finding the slope of segment MN. 2 over negative 1 is negative 2. So now I have my first slope. Now I need to find the slope of LK. So I'm going to go over here. I'm going to find the slope of LK. So I'm going to put a little LK equals of sub M. I got to know where my points are for LK. LK, I have the 6 and the 2. I'm going to subtract 6 minus 2 for the y's, subtracted by 2 minus 4 for our x's. 6 minus 2, 2 minus 4. 6 minus 2 is 4, negative 2. So now I have what the slope is of LK. The slope of MN is negative 2. The slope of LK is negative 2. Let me go to the picture to show you what that looks like. The slope of this one is down 2 over 1, and the slope of this one is down 2 over 1, down 2 over 1. It's the same slope. Earlier we wrote down, if they have the same slope, then they must be Parallel. Okay? Justify mathematically why they are parallel. Since they have the same slope, the two must be parallel. Mathematically, same slope, MN is parallel to LK. So I'm writing that down. I've already mathematically figured out what their slopes are. This is the mathematical way to do it without the picture. Bless you. But you could also go from one point to the other point and just say the rise. It's not rising, it's going down. Down 1, down 2, over 1, negative 2, positive 1, negative 2 divided by positive 1 is negative 2. You could figure out the slope that way as well. But you would need to draw your picture like you're doing this. And that's kind of how you show your work for that kind of stuff. Part D. Using the distance formula, find the length of MN and the length of LK. So I have to know what the distance of MN is. Where are my points? Here's M, here's N. I need to subtract the x's. So I'm going to make this formula, and it's going to be kind of big. I'm going to take M and subtract them. I'm going to do 1 minus 2. In parentheses squared. 1 take away 2 squared. And then I'm going to add the y's subtracted by each other, 3 minus 1 squared. And this is MN equals the length of MN. Order of operations states we have to do what's in parentheses first. 1 take away 2 is negative 1. Negative 1 squared means a negative 1 times negative 1. I'm just going to kind of write that in here so you can see it. If you ever plug this in your calculator, make sure you have it in parentheses. The most common error I ever get is that students don't use parentheses for negative 1 squared and your calculator does not know the difference. Actually, it does know the difference, which is why sometimes it will give you a wrong answer because of a wrong input. Negative 1 times negative 1 is a positive 1. 3 minus 1 is 2. 2 squared is 4. 1 plus 4 is inside this square root. The square root doesn't go away. 1 plus 4 means that MN is equal to the square root of 5.
Would it work the same if you squared everything inside the parentheses first and then...
I squared what first? Squared that and squared that?
Yeah.
It would not be the same, no. Then you're making some mistake in your squaring. I can show you later. This is one of the reasons why we learned the square roots on previous worksheets. If you think back to Unit 1, we learned the square roots because now we can leave our answer in radical form. This is in reduced radical form. We have now answered the first question, the length of MN. Now we're going to find the length of LK. LK equals the square root of, and I have to go back to what my L and my K were, 2, 6, and 4, 2. So I have to subtract my x's. I'm going to do 2 minus 4 squared and 6 minus 2 squared. Order of operations says do what's in parentheses first. 2 subtracted by 4 is negative 2. Square that. Negative 2 times negative 2 is a positive 4. 6 minus 2 is 4. 4 squared is 16. That's inside this radical. And so we have square root of 20. And I may or may not have shown this to you before, but the square root of 20 reduces. I have shown this to you. 4 times 5, 2 times 2. Here's a pair. It pops out. LK in reduced radical form, something you've learned how to do before, is 2 radical 5. If you would like to double check yourself with the calculator, your calculators, you can punch this whole thing in if you're good with the calculator, don't be afraid to use the parenthesis. 2 minus 4 parenthesis squared plus parenthesis 6 minus 2 parenthesis squared. I can punch that whole thing in, and your calculator will even do the radical down for you. That's how smart these things are these days. That's one of the reasons I recommended this particular calculator for you, the Casios, because it does things in radical form for you. Just to show you. Feel free to use that. Next question. Using the distance, this is, before I even go to the next question. How long is this? This is the Pythagorean Theorem. 1 squared, a squared plus b squared equals c squared. A squared is 1, 2 squared is 2. This is the square root of it, which is square root of 5. Same thing here. 2 squared plus 4 squared is equal to this squared, which is 2 root 5. Kind of stuff I want you to see. Part E. The length of MN is blank, the length of LK. If this MN is root 5, and LK is 2 root 5, how are these related to each other? What do you notice about these numbers? They are, how much? This is blank, the length of LK. What do you think goes there? If you know it, say it out loud. Awesome. One of you know. Whoever said that, good job for you. You're the only one who gets it. High five for you. Bam! There you go. Air high five. The length of MN is half the length of LK. Explain mathematically why this is true. So how do I prove that it is half? I can go MN equals 1/2 of LK. Watch. MN is root 5. LK was 2 root 5, which means that 2 root 5 divided by 2 is the same thing as root 5 is equal to root 5. That's a funky little proof, but we're proving that MN is half of LK because I can plug in LK and MN, and it's a true statement. That first page is the biggest concepts you are going to use in worksheet 4.1b. All of this work you should be able to do on your own. That's what I'm hoping you're going to be able to do on problem 2 by yourself. If you need examples, these are your examples. It's exactly the same thing except different points on number 2. The only other thing that you're going to have to be able to do is do a problem that starts off like number 3. Well, first and foremost, I'm going to give you a hint, and by looking at this picture. When we found the midpoint over here, and we found the midpoint over here, this red line is called a midsegment. And because it is a midsegment, thank you. Because this red line is a midsegment, it is parallel and it is half of the side it is parallel to. We can use that to solve problems. Let's look at number 3. I'm going to start number 3. I'm not going to solve it for you. B is the midpoint of AC. B is the midpoint of AC. If this is the midpoint, then what pieces are congruent to each other? Then BC must be the same as AB. You can add these congruent marks to number 3 because it says B is the midpoint of AC. It also says that D is the midpoint of AE. If D is the midpoint of AE, then AD must be the same. If this is the midpoint, then these two pieces must be the same thing as each other. And that must mean that this line, segment BD, must be a midsegment of this triangle. And the properties that we figured out for this triangle on number 1 are going to apply here. Let's add a few things. The measure of angle ADB, A, then D, then B is 70 degrees. Let's put the 70 degrees in the right spot, ADB. And the measure angle C is 60 degrees. 60 degrees. And BD is 12. When you get to number 3, they're going to ask you a variety of different questions. But what you're supposed to know for something like this is you're supposed to know that since this is a midpoint and this is a midpoint, this is called a midsegment. And midsegments are mathematically parallel to this line, and they're exactly 1/2 of the length of this other side. So I bet you that you can figure out what this length is. If this is 12 and it's half of this side, what does this side have to be? Super simple. Now, we said that this also has to be parallel to this side. Now, how is that going to help you? It's going to help you because of the corresponding angles. If you don't remember what corresponding angles are, we talked about them in Unit 3 and in Unit 1. If you have two parallel lines and here's a transversal, the corresponding angles, I'm just going to write it off to the side, corresponding angles are the ones that look like the letter F. They're the angles inside the letter F that are congruent to each other. I kind of see an F right here of the two parallel lines. This angle 60 is going to be the same as this angle right here. 60, what does this have to be? Because they're corresponding angles. And the same thing goes for this letter F down here at the bottom. If this is 70 degrees, then you should be able to figure out what angle E is as well. Because they're corresponding angles. And then you can do this. You can cover this up and you can actually figure out what angle A is because these add up to 180. Same with the big triangle, and you can figure that out. I'm not going to solve the rest of it because it's going to ask you to do that. What I'm going to do is I'm going to end your notes right there and give you the rest of the time to work on this worksheet in class.